Hi friends, welcome to my another video. This is the part 6 video in the series of G+4 building designing as per DEWA regulation. In last part 4 video, we have discussed the light load distribution in the corridor and inside the services room, and we prepare the circuit formation for the light load, and finally we have done the load schedule preparation for the light DB. In this video, we will make the power load distribution in the corridor and in the service room. After that, we will make the circuit formation for the distributed load, and then finally we will prepare the load schedule for the power load. In last video, I told you that in power we have three things. One is normal sockets, normal general purpose socket. Okay. Second, we have HVAC load. In that we have FCUs. And third, we have smoke purge system. What is this smoke purge system? Smoke purge system means there will be fan, and during fire it will run and it will extract the air from the corridor, so there will be no smoke during the fire in the corridor and people can escape through the emergency route. So these three load we have in the power system. Apart from that, we have some MSFD, okay, motorized fire damper, motorized smoke fire damper. For that we have to give also power. The designing will be, you have to think that what are the load required to facilitate the people residing in the building. So let's start this video. So we will first distribute the normal general purpose socket inside the corridor and in the service room. So let's start this one. We will put one general socket here. Okay. Then this is the electrical room. So we need one double socket here and one double socket here. This is the store, so we need one single socket here. This is the garbage chute room, so we need one single socket here. Then we need one socket here, single socket for the cleaning of the corridor. This one also is for the cleaning of the corridor. This is the long corridor, so the vacuum cleaner or anything they can plug here and they can clean the corridor. Now we need one single socket here also. In the water meter room, we need one double socket, but it will be weatherproof. Okay. We need now one power socket here. This is the telephone room, so the requirement will be more in the telephone room. This will be actually reflected in the telephone room drawing, but we will consider the overall load for the telephone room, and the spaceless supplier will distribute that load according to their panel. So we will make 4 double socket in the telephone room. Now we have completed the general purpose socket distribution in the corridor as well as in the services room. Now we have FCUs. Here we have one shaft from where the fresh air duct will come. So here we have one FCU. So we will place one spur outlet here for the FCU. Okay. Now we have one shaft here. So there will be one FCU for the fresh air. There is a shaft. So there will be one FCU here and there will be one FCU here. The FCU here will feed this corridor, the FCU here will feed this corridor, and the FCU here will feed this corridor. Apart from that, we have 3 smoke purging system. Here you can see that there is an opening for the MSFD. So we have one fan here. So we will make symbol of fan, smoke purging fan. One fan will be here. So there will be one isolator here for the fan. Here also we have one smoke purging system. So we will write the fan symbol and there will be one isolator for that fan. Here also there is one smoke purging system. So there will be a symbol of fan and there will be one isolator. Okay. Now we have distributed the general load and the smoke purging system and the FCU load. We have some MSFD. We have to think where will be the MSFD. Motorized damper. So with the fan there will be one motorized damper. So we will make one spare outlet for the MSFD. With this fan we have one MSFD, so we will put here MSFD. We have one damper here, so we'll put one MSFD. Now we have completed the MSFD for the smoke purge system. As I told you, near the FCU there is one shaft, and from that shaft duct will come and it will supply the fresh air in the corridor. But during the fire, this fresh air has to stop. So there will be a damper that will stop that will close during the fire. So we have to put one spur outlet for MSFD where there is a fresh air duct. So we have in this shaft also, so there will be one spur outlet MSFD, and here this shaft there will be one MSFD. Hope you are clear now. What is the difference between the smoke purge system as MSFD and in the fresh air system MSFD? During the fire, suppose there is fire happen here, so it will create smoke. So in the normal time, in the normal condition, this smoke purging fan is closed all the time, okay? And once the fire is detected, then this MSFD will open the damper and fan will run, and it will extract the air from the corridor, smoke from the corridor, and it will release to the open atmosphere, okay? Open atmosphere from here and in here. But in case of fresh air, all the time this MSFD will be open in normal condition, and it will supply the fresh air to the corridor. But once the fire detected, then fire is occurring, it will increase more and more when there is a fresh air, when there is oxygen. So we have to reduce the oxygen, we have to cut the oxygen in the fire zone area. So the damper should close. So during fire, the damper will close. So we need one MSFD which will be closed, which will be open at the normal condition and closed when there is a fire. But opposite of that, the MSFD of the purging fan will be closed all the time, and in the fire it will be open. Hope you are clear with this concept. Now we have completed all the power load distribution inside the common area and in the service room. Hope you are clear now. Here we have one garbage chute. Garbage chute also we need one MSFD motorized damper. During normal condition this will be open, but during fire it should close. So the fire will not, suppose fire happen in first floor, it should not go to second floor. So when the shaft will be closed, then the fire of first floor will be remain in the first floor, and it will not spread to the second floor, third floor, or in the ground floor. So there will be one MSFD for the garbage chute. Hope you are clear now. You have to think what are the system required to facilitate the resident residing in that building. Now let us start the circuit formation for the general purpose socket first, then to the smoke purging fan, then to the FCU, and lastly we will do the circuit formation for the MSFD. So let us start with the general purpose socket. So here we have one general purpose socket. So it will be looped with this will be looped with this will be looped with this will be looped with this, and this will be looped with this. So 1, 2, 3, 4, 5, 6, 7, 8. So as there is a 8 number of socket in the loop, so it will be ring circuit. It is going to dB, it is also going to dB. Now we will write the purging fan circuit now. So it will be again R circuit, okay. Now we have completed this corridor general purpose socket and the purging fan. Now let us move to this side corridor, So we have here two sockets. If you remember, during the circuit formation of light load, we have given this corridor as a Y circuit. So for the power load also we will try to give yellow circuit in this corridor. So there is 3 sockets in here, 2 double socket in the water meter room and 1 socket in the corridor. So we will make the circuit formation and it will go to dB. Here there is a smoke purging fan, so it will be also yellow circuit and it will go to dB. Now let us move to this corridor, and as you remember, this corridor we have given to blue circuit when we are making the light circuit formation. So we will try to take blue circuit for the power load also. So here there is a 1 general purpose socket and here 1 general purpose socket. So it will be radial circuit and going to dB. Here we have 1 smoke purge fan, so it will also go to dB and it will be blue circuit. Now it is clear, right? Now we will go to the FCU. Here we have 1 FCU in this corridor. So the circuit will be red circuit and it is going to FCU dB. Okay, red circuit. Here we have 1 FCU and this will be yellow circuit, so it is going to dB. And here we have 1 FCU, so it will be blue circuit and it will go to dB. Now we have to give the circuit formation for the red for the MSFDs. Okay, so let us start with this corridor. So here we have 3 MSFD, 1, 2 and 3. So it will go to dB. It is clear, right? Now we have two MSFD here, one for the fresh air, one for the purging fan. So we will make the circuit formation for this two MSFD, and it will be yellow circuit going to DB. Here also we have two MSFD, one for the purging fan and one for the fresh air. So it will be blue circuit and it will go to DB. Now what is balance in the full plan? It is telephone room only. So what we will do, we will give one blue circuit and 2 dB, and we will give one yellow circuit and it will go to dB. Now we have completed the power circuit formation for the common area and the service room, and we cover all type of power load: FCU, MSFD, general purpose sockets, and the smoke purging system. Now I will make it little bit presentable, and then again I will come back to this video and I will write the circuit number, circuit identification number for each circuit, and then we will tabulate it in the load schedule. Before making the circuit formation for the power load, let us write first the load on each power load. So as we discussed many times, for the single socket the load will be 200 watt. I will not write everywhere because the space is very limited. So for this socket it will be 400 watt. For double socket 400 watt, for single socket 200 watt, single socket 200 watt, and so on for general purpose socket. Now for the FCU, the load on FCU is, the rating of FCU is 300 watt, and all the FCUs are typical. So the load on the FCU is 300 watt. The load on the FCU is 300 watt. How I got to know that the load on the FCU is 300 watt? By referring the approved material technical submittal for the FCUs and FHUs. Okay. Now, as per the DEWA regulation, the load assumed on one MSFD will be minimum 100 watt. So the load on each MSFD will be 100 watt. Okay. On each MSFD, for this MSFD, for this MSFD, for this MSFD, for this MSFD, for all MSFD, the load assumed is 100 watt. Now we left with the smoke purging fan. The load on the smoke purging fan is 200 watt. Okay, how I know that the load purging fan has 200 watt load? By referring the ventilation fan technical submittal. This I will explain you when I will go for the discussing the material submittal. I will make separate video on that, how to refer the material technical submittals and how to extract the load from the material technical submittal. Okay. Now for all MSFD the load is 100 watt. For the purging fan, all purging fan, the load is 200 watt. For the MSFD it's 100 watt. For FCU it is 300 watts. Now we can make the circuit number identification. But here I want to highlight one more thing. As I discussed in the flat video also, the FCU is controlled by 100 milliampere and the fans is also controlled by 100 milliampere ELCB. MSFD is a general is a power load, and the general socket is also a power load. So these all are controlled by 30 milliampere. I hope now you are very clear what are the load of each power load and what are the ELCB rating for each power load. Now we can give the circuit formation by considering this ELCB sensitivity rating. So first we will go for the general purpose socket. So here I will write R1. Okay. So R1 will be here also, as it is a ring circuit. So R1. Now we will go to B1. So here general purpose socket is here. So I will write Y1. And for blue circuit, this is the general purpose socket. So I will write B1. Okay. Now we have MSFD also controlled by 30 milliampere. So after general purpose socket, we can write the load circuit number for the MSFD, but we cannot write for FCU because FCU is controlled by 100 milliampere and the power socket is controlled by 30 milliampere. So we cannot put these two different ELCB in one section. Okay. So we will go for the MSFD. So we will write here R2. Okay. For this MSFD, this MSFD, this MSFD. For the Y circuit, we will write here Y2. For the blue circuit, we can write here B2. Now we finish this MSFD, but here we left with 4 double socket. So we will write here R1, Y1, B1 we used, R2, Y2, B2 we used. So R3 is not there. So it will be B3 and it will be Y3. I hope it will be very clear to you. I am explaining in step by step. Okay. Now we will give the circuit number for the smoke purging fan. So we have given till B3. So we will start from R4, Y4 and B4. Now we can go for the FCUs also. So I will write here for FCU R5, Y5 and B5. Now we have done all the circuit formation. Now we will go for the load schedule tabulation as per DEWA approved format. Now let us start the tabulation of load as per the circuit provided in the layout. So first is the R1 circuit. So here is the DB R1 circuit, and in that there is total 8 general purpose socket in the corridor, in the electrical room, in the store, in the garbage chute, and again in the corridor. So I wrote here corridor, electrical room, garbage chute, store. Okay, total 8 number of sockets, and the corresponding load is 200 watt per single socket. So the total load is 200 into 8, that is 1600 watt. Now let us move to the other circuit, that is Y1. Y1 is here, Y1, which have the 3 single socket, or we can say 1 double socket and 1 single socket. So we can say 3 single socket, and the corresponding loads is also mentioned in per unit, that is 200. So the load on Y phase due to Y1 is 200 into 3, that is 600 watt. Now let us move to the blue phase. Here you can see B1 is having 2 single socket. So here I mention B1, which is in the corridor and lift lobby. Here it's corridor and here it's lift lobby. So the number of socket is 2, and the corresponding per unit load is 200 watt, and the total load is 200 plus 2, that is 400 watt. Now let us move to R2 circuit. R2 circuit is corridor and garbage chute, and it is spur outlet for MSFD. Spur outlet for MSFD 3 NOS. So we'll check in the plan. Here you can see that R2 circuit, which is having the spur outlet for MSFD, which is 3 NOS, 1, 2 and 3. And the per unit load on the MSFD is 100 watt, as I told you in beginning also. Here I mentioned 100 watt. So the total load on R2 circuit due to MSFD is 300 watt. Now let us move to the Y2 circuit. Y2 circuit is also MSFD load, which is in the corridor, and the total MSFD in the Y2 circuit is 2 NOS. So here we can see that Y2 circuit, which is having 2 MSFD in the loop, so the total load is 200 watt. Okay, in same way for the B2 circuit, which is in the corridor and have 2 number of MSFD. Here you can see the 2 number of MSFD, and the corresponding load is 100 into 2, that is 200 watt. In the layout, if you will see here is the MSFD B2. Okay, now let us move to the R3 circuit. R3 is a spare, and Y3 is 4 single socket in the telephone room. So I wrote here Y4 is Y3 in the telephone room and has 4 single socket. In same way, B3 in the telephone room and have 4 single socket. Okay, now R4. Let us move to the R4. Here you can see that before I wrote this purging fan as R4, but when I was tabulating the load in the load schedule, I find my load is unbalanced. So what I did, and my load on the blue phase is less and R phase is more. So what I did, I shifted that R phase load to the B phase load, and once I did this one, my load is become balanced. Here you can see that 2200, 2100, 2100. So it's very balanced load. So before in the circuit formation, I wrote it as R4, but after try and trial method, I changed it to B6. Here you can see that B6 corridor 1 fan smoke purge, and the load of the smoke purge fan is 200 watt. Here you can see, and the total load on B6 circuit due to purging fan is 200 watt. Okay, now let us move to Y4 circuit. Y4 circuit is in the corridor, and it is again the purge fan, and the total load is 200 watt. In same way for the B4, it is in the corridor and it is again a purging fan, and the total load is 200 watt. If you will see in the layout, here you can see that Y4 is a purging fan and B4 is a purging fan load. Okay, now let us move to the R5 circuit. R5 circuit is in the corridor and it is feeding to FCU. Okay, and in same way Y5 FCU and B5 FCU. If you will see in the layout, here is the FCU which is R5, here is the FCU which is Y5, and here is the FCU which is B5, and the load is 300 watt per FCU. Here you can see that one, 300 load, and the total load is also 300 because one circuit have one FCU. Now we completed the load tabulation, and I already discussed in detail how to write the wire size and the MCB size and the ELCB size in my previous video. I took here 30 milliampere for the general purpose socket and MSFD, and I use 100 milliampere ELCB for the FCU as well as for the smoke purge fan. Hope you are clear now. The total connected load on this DB is 6.4 kilowatt. The current on the DB will be as per the three-phase formula, that is P by √3 into V into cos phi. So I got the ampere rating as current on the DB is 10 ampere. With the safety factor, it is 13.7 ampere. When I took the safety factor as 1.5, then the current on the DB is with the safety factor 16.4 ampere. But as the sub load have the ELCB rating as 40 ampere and the MCB rating is 20 ampere, so it is illogical to write here the main breaker rating less than the sub main breaker rating. So I match it and I wrote it 40 ampere triple pole isolator. Okay, the cable size for this 6.4 kilowatt is 4 square mm wire is also enough, but I wrote 6 square mm wire with considering all safety factors. Hope you are clear with this topic, that how to distribute the power load in the common area and how to do the circuit formation for the power load in the common area. As of now, we have completed 5 parts in the series of G+4 building designing, and in that 5 parts we make the load schedule for 1 BHK flat, we made the load schedule for 2 BHK flat, we made the load schedule for the common area light loads, and in part 5 video, which is this video, we made the load schedule for the power load in the common area. From that, in next part video, what I will do, as we know the load of each DB, all flats DB, light DB and power DB. As you can see, for the light DB, we have the load of 3.35 kilowatt for the common area, and for the power DB, we have the load of 6.4 kilowatt for the common area. So now, in next video, that will be the part 6 video, I will make the designing of SMDB first floor, and it will be typical for the SMDB second floor, SMDB third floor and SMDB fourth floor, as the whole floor is typical with floor number 1. So we will make the designing of SMDB first floor, we will make the SLD and the load schedule for the SMDB first floor in part 6 video. So stay tuned and watch all my videos related to G+4 building designing as per DEWA regulation. I hope you find this video informative and you learn something new from this video. If you really find my video informative, then please subscribe my channel, hit the thumbs up button, press the bell icon for the future videos update, and moreover to that, react in the comment section that how you find this video for you and suggest me for any feedbacks. And kindly share my video with your electrical friends, so this video will reach to many electrical engineers and electrical professionals. We will meet in part 6 video. Till then, take care, keep learning, and bye-bye. Thank you so much.